Hi everyone, this is Kamal. Welcome to my channel Understand Tech here. In this video, I'm going to explain how to do 1's and 2's complement subtraction. I'll be explaining in a step-by-step manner, so you might want to pause the video at various points and see how things are done. So let's start. Let's start with 1's complement subtraction first. There are two ways you can do 1's complement subtraction without reversing and reversing bits of subtrahend. Let's first discuss without reversing bits. These are the rules for carrying out 1's complement subtraction. Okay, let's take an example and let's say we are given this to subtract. Let's try to apply rule 1. This part is called minus while this part is called subtrahend. See minus and subtrahend? There are 6 bits in minus and only 5 bits in subtrahend. So number of bits are not equal in minus and subtrahend. According to rule 1, we need to make minus and subtrahend to have equal number of bits by adding zeros in their insignificant positions. An insignificant position is a position where adding extra zero does not make difference. This is an insignificant position. Therefore, add 0 here. Now, both minus and subtrahend have equal 6 bits. So we have applied rule 1. Okay, now let's try to apply rule 2. According to rule 2, we need to find 1's complement of subtrahend. 1's complement of any number is obtained by subtracting it from equal number of 1's. Thus, 1's complement of subtrahend can be found by doing this. On subtracting, we get this. By definition, this is 1's complement. Now let's apply rule 3. According to rule 3, we need to add minus with the result in step 2. This means we need to do this. On adding, we get this. Now we need to apply rule 4. What does the rule 4 says? It says if the result in step 3 produces n carry, then answer is positive and is obtained by removing and adding the n carry to the result in step 3. Here we have an n carry. So according to the rule, we have to remove this n carry and add it. On adding the n carry, we get this. Note, rule 5 does not apply here. This is the final answer. Now let's do 1's complement subtraction by reversing bits. This method is very similar to the method we discussed earlier. In fact, the only difference is while finding 1's complement of subtrahend. Anyway, these are the rules for carrying out 1's complement subtraction. Let's say we are given this to subtract. Let's try to apply rule 1. This part is called minus, this part is called subtrahend. Look at minus and subtrahend. There are 6 bits in minus, 5 bits in subtrahend, so number of bits are not equal. According to rule 1, we need to make minus and subtrahend to have equal number of bits by adding 0 in their insignificant positions. This is insignificant position, therefore add 0 here. Now both minus and subtrahend have equal 6 bits. Now let's try to apply rule 2. According to rule 2, we need to find 1's complement of subtrahend. 1's complement of any number can be obtained by reversing individual bits. Thus 1's complement of subtrahend can be found by doing this. Now let's apply rule 3. According to rule 3, we need to add minute with the result in step 3. This means we need to do this. On adding, we get this. Now we need to apply rule 4. According to rule 4, if the result in step 3 produces an AND carry, then answer is positive and is obtained by removing and adding the AND carry to the result obtained in step 3. Here we have an AND carry. According to the rule, we have to remove this AND carry and add it. On adding the AND carry, we get this. Note, the rule 5 does not apply here. This is the final answer. So, we have done the 1's complement subtractions by reversing bits. Now let's look at how we can do subtraction using 2's complement method. Again, there are two ways to do 2's complement subtractions, one without reversing and other by reversing bits of subtrahend. Let's first do subtraction without reversing bits. So these are the rules for carrying out 2's complement subtraction. Let's say we are given this to subtract. Let's try to apply rule 1. This part is minute, this part is subtrahend. Look at minute and subtrahend. There are 4 bits in minute while 6 bits in subtrahend. So number of bits are not equal in minute and subtrahend. According to the rule 1, we need to make minute and subtrahend to have equal number of bits by adding 0 in their insignificant positions. This is insignificant position, therefore add 0 here. Now both minute and subtrahend have equal 6 bits. Now let's apply rule 2. According to rule 2, we need to find 2's complement of subtrahend. To find 2's complement, we need to first find 1's complement. 1's complement of any number is obtained by subtracting it from equal number of 1's. Thus, 1's complement of subtrahend can be found by doing this. On subtracting, we get this. By definition, this is 1's complement. To find 2's complement, we need to add 1 to 1's complement. So we need to do this. In doing this, we get this. Well, by definition, this is 2's complement of subtrahend. Now let's apply rule number 3. According to rule number 3, we need to add minute with the result obtained in step 3. This means we need to do this. On adding, we get this. Note, rule 4 does not apply here as there is no AND carry. Okay, so let's try to apply rule 5. According to rule 5, we need to find 2's complement of the result in step 3. To find 2's complement, we have mentioned above, we need to first find 1's complement. 1's complement of subtrahend can be found by doing this. On subtracting, we get this. By definition, this is 1's complement. To find 2's complement, we need to add 1 to 1's complement. That means we need to do this. In doing this, we get this. This is 2's complement of result in step 3. The final answer is, why negative sign here? Well, that's what the rule 5 says. Rule 5 says answer will be negative. Therefore, negative sign here. Now let's look at how we can do subtractions using 2's complement method, but this time by reversing bits of subtrahend. Again, these are the rules. Okay, let's say we are given this to subtract. Let's try to apply rule number 1. This part is minute. This part is subtrahend. There are 4 bits in minuend, 6 bits in subtrahend, so number of bits are not equal. According to rule number 1, what we need to do? We need to make minuend and subtrahend to have equal number of bits by adding zeros in their insignificant positions. So this is insignificant positions. Therefore, let's add 0 here. Now both minuend and subtrahend have equal 6 bits. Now let's apply rule number 2. According to rule number 2, we need to find 2's complement of subtrahend. To find 2's complement, we need to first find 1's complement. 1's complement of any number is obtained by reversing individual bits. Thus, 1's complement of subtrahend can be found by doing this. To find 2's complement, we need to add 1 to 1's complement. In doing this, we get this. Well, by definition, this is 2's complement of subtrahend. Now let's apply rule number 3. According to rule number 3, we need to add minuend with the result obtained in step 3. On adding, we get this. Now, the rule 4 does not apply here as there is no n carry. According to rule number 5, we need to find 2's complement of the result in step 3. To find 2's complement, we have mentioned above, we need to find 1's complement. 1's complement of subtrahend can be found by doing this. To find 2's complement, we need to add 1 to 1's complement, so we need to do this. In doing this, we get this. This is 2's complement of the result in step 3. The final answer is, why negative sign here? Well, that's what the rule 5 says. Rule 5 says answer will be negative. How's today's video? Please leave your comments and suggestions below. I would be posting videos like this on various computer technology topics, so please do consider subscribing to my channel. So this was for today. Thank you so much for watching this video. See you in next one.